Hi everyone, my name is Adrienne and I'm going to be presenting to you Chapter 19 on experimental models and model experiments. So the chapter ideally focused on identifying what an experimental model is, as well as what a model experiment is. And although they are similar in their names, the differences are quite extravagant. So we'll be talking about the differences between the two as well. And then additionally, I'll also be discussing with you some implementation ideas in which you could use within your classroom setting if you haven't already done so. So experimental models is the first thing that the chapter discussed. Ideally, this is something that is created to prove an unproven idea. So the examples in the book are ones like, for example, that I've written here, an airplane. Engineers are curious about how an airplane can successfully complete a takeoff when, limiting either the length of the runway or other aspects of the airplane. So an experimental model is basically created to prove that the lift could be achieved in such a case. Another one is obviously fuel-efficient cars. So ways in which cars can run efficiently with minimal fuel or with a different type of fueling. So obviously we have cars that kind of are electric in a sense and that you can kind of charge up the same way we would charge a phone. So ideally those are all experimental models that were created then. The biggest thing to understand about experimental models is that they are not to be confused with a test model. So like a test model would be something that a car that you would use in the sense of testing its ability to withstand a crash and kind of what happens to the car when a crash occurs. So ideally these experimental models, they are created and ideally, when successful, they ultimately do produce a small portion of these. Now these don't always make it to mass production, but they are produced to some extension. In the picture here, I also included the smart car because that was something that we had talked about earlier in the course, and how these are ideally experimental models as well that we are still experimenting with. So model experiments, so look at the next vocabulary word that was used, is basically used to help scientists gather information to ultimately solve or identify problems. So the quote that I thought best fit for this was, it's a structured set of carefully contrived and or controlled conditions used to obviously observe the effects. And I think these are the ones we see most likely within our classroom setting. Because we do a lot of experiments, STEM fair projects in which we're controlling everything and ultimately looking and seeing what different variables cause an output. So obviously the classroom integration when we look at model experiments is, there's so many different options and I'm sure we all have even more. These were just a few that I thought would be some great ones to kind of put out. So any type of model experiment, when you look at weather conditions or natural disasters, we can create a ton of model experiments in those to kind of see what happens and kind of see the ultimate effect of certain things. Also, kind of creating your own water filtration system. That's ideally something that would be a model experiment, kind of changing things up, controlling the variables, ideally seeing which materials could be used to provide the best filtration system. So those are just a few, and I'm sure there's tons more that we do every day within our own science or STEM classrooms as well. So when it comes to experimental models, this was a little bit harder because ultimately you'd be looking at designing something that students would ideally create for the sense of answering a problem. So one thing I actually did end up finding was the Design Squad Global. It's a website in which they have different STEM projects you can do, but they also kind of do, and I have the picture here of kind of the website, where they ask a question and kind of propose a real world problem in which students would help design a solution for. And this really connects a lot with our innovation projects that we're working on. So ideally, identifying a problem, and then working at designing and creating a solution for it. So the Design Squad Global, definitely recommend checking it out. Like this was just one, the create a reusable napkin that cleans itself. I thought that was pretty unique. A pair of sneakers that put themselves on. Obviously these are more kid-friendly and can ideally be a wide range of ages that could work with. So it's not, although designing it and everything might be more of a older group of children, it can still work with primary students. In a sense, one way that I have implemented experimental models is I've had students create toys and stuff out of recycled objects. So in a sense, they design their own kind of game or toy and they create it, which ultimately that could go into production if they wanted to. But ideally it's just used to kind of show that they're able to create something out of what most people would consider their trash versus having to go out and always buy stuff. Another great website that is kind of great for designing things is Teach Engineering. So if you haven't already checked it out, definitely recommend it. And it is a K-12 website, so that's a way for even the primary students to get a piece of it, as well as the older kids. And it really provides you with real-world problems that students are able to then tackle. So that's the basic of Chapter 19. It was pretty short and sweet, with just a lot of examples about the experimental models and model experiments. But the biggest takeaway is just understanding that we do a lot of model experiments, but experimental models is actually the creation and the designing with the intention that it will successfully be reproduced for the community around you or for your target audience in which you're looking at providing for. So that is Chapter 19. I hope you guys enjoy, and let me know if you have any questions.